Standards identified in these activities have been adopted from the content standards of the national organization for each discipline. More information on this can be found in the Technology as Facilitator of Quality Education model. The students must devise and implement an experiment that will help them determine the relationship between force, mass, and acceleration. They then have to collect and analyze data from the experiment to draw their conclusions. This activity implements Science Standard A1 and A2 for grades 9 through 12, which require that students perform and understand aspects of scientific inquiry.
Now you're going to have two things that we're going to be looking for. First thing is a plan. I want to know what you're doing. What are you going to do? What's the plan? Second thing is I need to see what your data is going to look like. How are you recording your data? What are you recording and how are you recording it? And then finally, what are you going to plot or what are you going to graph for me so that we can find a relationship between these three variables.
As they conduct their experiments on force, mass, and acceleration, and to analyze their data, the students address Science Standard B4 for grades 9 through 12. This standard requires that students study and understand motions and forces.
Measure in centimeters?
12 centimeters.
No,
But
we're
we
doing
measure it that way.
Well,
Get back
this
together, we
is
got to make sure everybody shares that data.
7.5 centimeters.
Okay.
How do you want? How is that? What unit is that in?
0.075.
Read it.
See, that is
Okay.
genius.
Yeah. That'd be 7.5 centimeters. Because that's in
Is
meters.
it in meters? Okay, so that's good then.
Yeah. You can close it.
Please don't let it go. You ready?
Ready? So then 0.069 and 1.07. Okay?
Want me to do 200 again?
Yeah.
0.0695.
1.07.
Okay.
Okay, if we look at the variables, you need to have a relationship between mass and acceleration. The mass goes up, what happens to the acceleration?
Acceleration increases. Okay, I can do that.
Do we have that? Do we have that number? When we went at the end.
Yeah, our acceleration is going up pretty constant.
Accelerations with force. Force and acceleration. If I look at those two.
It's pretty relative.
Okay.
I'm just going to go 0 to 10.
You're getting what? Something on that order? Curve? Straight? What is it?
Pretty straight.
Pretty straight?
About 1 for every 10.
Okay. What's going to happen if all of a sudden I start loading weight on here and keeping the force the same? What's going to happen?
Put mass in the car. Acceleration's going to go down.
It's going to go down. So if you talk mass and acceleration, what are you talking about? What kind of shape?
Why don't you write them down?
Hyperbola?
Write them down next.
So you're saying inversely relationship.